Okay, so number 1, it says baby elk. Biologists estimate that a randomly selected baby elk has a 44% chance of surviving to adulthood. Assuming this is correct, suppose they select 7 baby elk at random, and X is the number that survived to the adulthood. Okay, so we want to know if it's binary, if it's binomial. So either they survive or they don't. Okay, so check. Independent. One does not affect the other necessarily. N, number of trials. N is equal to 7, so 7 trials, check. And the probability is 44% each time. So yes, it is binomial with N is equal to 7 and P is equal to 44%. Okay, number 2. Okay, so Lawrence likes to shoot bow and arrow in his free time. On any shot, he has about a 10% shot of hitting the bullseye. As a challenge, one day, he decides to keep shooting until he hits a bullseye. X is the number of shots he takes. Is it binary? Yes. He either hits or he does not. Independent? We can say it's independent. One shot doesn't necessarily affect the other shot. Okay, this is where it's wrong, though. Well, here we have probability is 10% each time, okay? But there's no set number of shot. It says that he's gonna keep shooting until he gets a bullseye. So therefore, it's a not binomial. Okay. The third one. Okay, we're looking at this elk one here. It says find the probability of exactly 4. So probability that X equals 4, that exactly 4 of the 7 elk live. Okay, so that means we want, there's 7 elk, so we want 4 of them to live. So the probability they live is 44%, and we want 4 of them to live, which means, okay, the opposite of this would be 54%, 56%. Okay, so probability they live, we want 4 of them. Probability they don't live, there's a total of 7, so we want 3. 3 of them would not live. Now there's different combinations there. Remember, that it could be the first 4 that live, or this one they live and don't live, or so forth. So we have to think how many combinations there are of them, of 7, and we're choosing 4 of them to live. Okay, so 7 combination of 4 living, but 30 would be 35 times 4 of them living and 3 of them not living. Okay, so there is a 23% chance that we will have exactly 4 elk live. Okay. The fourth problem. Okay, it says make a histogram of the distributions and describe its shape. Okay, so we could have 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 elk live, right? Okay, so those are the possible outcomes. So we already found 4. Exactly 4 was 23% of them. Okay, the probability of, we'll have to find the others, and then we can do the histogram. Probability that X equals 0 means that they all live, all die, I mean. Okay, the probability of live is this, probability of die is this. So we have probability of them dying, we have all 7 of them dying. Probability that all 7 die is 0.017, so basically 0.02. Probability that 1 lives, so 1 will live, 44% chance of that, and then the other 6 die. And how many different combinations are there of 7 choosing 1? Okay, so math, 7 choose 1, there's 7 different ways, right? Okay, times 0.44 times 0.56 raised to the 6. gives us 0.09. So 9% chance that exactly one would live. Probability of exactly 2 will live. So we'll have 2 living and 5 that don't live to adulthood. And how many different ways can we arrange those 2 that live? Okay, 7 choose 2. There's 21. Okay, 21 times 0.44 to the second times 0.56 to the fifth is about a 22% chance of exactly 2 of them living. Probability of 3. We have 3 living and 4 dying. So 7 choose 3 is 35 times 0.44 to the third times 0.56 to the fourth. It's about 29%. And then 23, okay, we already got that one. And x equals 5. I think we're going to see this probability start going down again. Okay, so we have 5 of them living and 2 of them not living. How many different ways can they do that? Choosing 5 of them. Okay, 21 different ways times 0.44 raised to the fifth times 0.56 raised to the second. About 11% chance of that happening. Okay, so you want 6 of them to live and 1 that dies. Okay, 7 choose 6 or 7 times 0.44 raised to the sixth. Hold on, there's only 7. There'd be 1 here, right? 6 and 1 more there. Okay, 6 of them live times 0.56 to the first is about almost 3%. And probability they all live, okay, would be 0.44 to the seventh, which is almost 0% chance, 0.003. Okay, so now I can make that histogram. Okay, 0 happened 2%, 1 happened 9%, 2 happened 22%, 3 happened 29%, 4 happened 23, 5 was 11, 6 was 3, and 7 was almost 0. Okay. Describe the shape of this. I'd say it's approximately symmetrical. Okay. The 5th question for homework. An online spinner has 2 colored regions, a blue and a yellow. According to the website, the probability spinner lands in the blue is 80%. You can see that in the picture there. So that means 20% over here. Assume for now that this claim is correct. Suppose we spin the spinner 12 times. Okay, so there's our n, right, our set number of trials. And we have our probability, so it's binomial. Explain why it is a binomial. Okay. So thinking bins, it's either x's number ends in blue. So it's either blue or it's not blue. One spin is independent of the other. The set number of trials is 12, and the probability of getting a blue is 80%. So we know it's binomial with n is equal to 12 and P is equal to 80%. Okay, so part B then says probability that X equals 8. Okay, so 8 of them, of the 12, to be blue, right? So I know that I want 80% chance of blue, and I need 8 of them to be blue, which means there's 20% chance that it's not blue, and I need 2 of them, to be a total of 10, right? 2 of them to not be blue. How many different ways are there to get 8? Okay, so it'd be out of 10 of them that we want 8 of them. Oh, I'm sorry, it's 12 times. They're spinning it 12 times. I should have saw that. So this is wrong, and this is wrong. So it'd be 4, right? 4 there, 8 blue, 4 non-blue to make 12. And how many different ways are there to arrange 12 out of 8? Okay, so I have 12 choose 8 is 495 times these. Okay, gives me about 13% chance. Okay, and then the last part here, we want to actually make the distribution. Okay, so got a little bit of work. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so how many could we have blue? We could have 0 blue all the way through 12 of them being blue. Okay, so we got to figure these out. Okay, so this is number 6 in the homework. Okay, so we already did the probability of 8 to be about 13%. Okay, we did that problem over here. Okay, so the probability, let's go through all these different probabilities, that none of them are blue. None of them are blue would be all of them, all 12 of them not being blue. So 0.2 to the 12th is almost 0. 0.00, yeah, almost 0. Probability of 1 is we have 1 of them being blue, and we have 11 of them not being blue. And how many different ways are there to select 1 from 12? Well, there's 12 different ways. I can show you my calculator steps that I'm doing. Okay, that also is 0.0000, almost approximately 0. Okay, a lot of these lower ones are not going to really happen. Okay, 12 choose 2, so 80% of them. Okay, 2 of them are probability of getting blue, and the probability of getting 10 of them not blue. So you do this in Desmos. I'm using the calculator instead. So 12 choose 2 gives me 66 different ways, times 0.8 to the second, times 0.2 to the 10th, approximately 0 as well. Oops, that was 2. Probability of getting 3 blues, only 3 blues, not more than that. So how many different ways are there to do that? Would be this. So it would be 9 of them that are not blue. So choose 3. There's 220 different ways of doing that. That's also almost about 0, right? 0.00005. Okay, we just say that's approximately 0. So 12 choose 4, exactly 4 of them being blue and 8 of them not being blue. So 12 choose 4, there's 495 different ways there. Okay, that's 0.00005, almost to 0 again. Okay, so really not much of a chance I'm not going to get too many blues, right? Okay, I'm going to get some blues here. Okay, probability of getting 5 12 choose 5, with 5 of them being blue and 7 of them not blue. Okay, so there's 792 different ways of choosing those 5. Times 0.8 to the 5th, times 0.2 to the 7th. Okay, so we get 0.003. We're getting closer to actually probably something may be happening. I don't know why I put that there, anyway. So if you think about this, the probability says you're going to get some blues, right, every time you do this. So the probability of getting exactly no blues, not very likely. Probability of only getting 1 blue, if you roll it 12 times, not very likely, right? So we're starting to get, we expect more and more blues, right, because there's more and more that is blue. So we'll see that here. So 12 to 6 is that many different ways. .024. So we want 5 of them being blue, and hold on, there should be 12 here. That's 12, that's 12, that's only 10. Should be 6 and 6 here, right? Let me go back. Anyway, I'll go to this one. So we have 7, and then 5 would not be. I'll go back to this one. That was 924 times 0.8 to the 6 times 0.2 to the 6. Okay, 7. Okay, 12 choose 7. There are that many different ways of choosing 7. Times 0.8 to the 7th. Times 0.2 to the 5th. Now we're going to start getting a little bit more of a chance of it happening. So 5% of the time you might get exactly 7. 13 you get exactly 8. Okay. Probability of 9. 9 of them that are blue. 3 of them that are not. So 220 different ways of doing that. Times these probabilities. Now we're going to start getting somewhere. There's about a 24% chance of getting exactly that many. 9 out of the 12. And getting 10 of them. Be 66 different ways. Times 0.8 to the 10 times 0.2 to the 2. Okay, is about a 28% chance of getting 10 out of the 12 to be blues. And 11. And 1 not being blue. So there's 12 different ways to arrange them. And then times 0.8 to the 11th. Okay, about a 21% chance of 11 happening. And the probability of getting all of them would be 0.8 to the 12th. About a 7% chance. Okay, so we got all of our different probabilities there. Now we have to put them into a histogram. Okay, so we'll go 10%, 20%, 30%. So these bottom ones here is almost a 0% chance of any of these happening down here. Right here we start at 1%, so right here we get like 1% here. 7 we start to get to 5%. Okay, then 6 we get to 24%, and we really start to jump here at 6. I mean, sorry, at 8. Sorry, 8 was, I should look up here, 8 was 13%. 9 got up here to 23%. 10 got up to 28%. 11 was 21%. And 12 was 7%. Okay, so definitely, if you look at this shape, it's skewed. This part's approximately symmetric, but we do have some things out here, so it's skewed left. Okay, and we can see that if you think about this, if I'm spinning this 12 times, I would expect more blues, right? And the highest probability would be 10 out of those 12 being blue would be the highest probability. You know, you might get some other ones here too, but if I'm spinning it 12 times, probably I'm not going to get very many blues there. Okay? Come to class with some questions.